Today we're going to talk a little bit about the ITD. Before we start about the ITD, the Innovation Technology Demonstration Work Group, I just would like to talk with you guys about innovation. So often when we think about innovation, we are just too busy to try something new. We are happy doing what we're doing, and we don't have a lot of time to try nothing new. So we are so busy that we feel that we really don't have the time to try anything else. However, innovation is extremely important. Uh, on this slide, we have the infrastructure bill. The infrastructure bill is a $1.2 trillion package that specifically addresses innovation. And I just thought that was very interesting. So here are some of the terms that we see on this $1.2 trillion bill. So a lot of very interesting terms, and one of them is future-proof. We can see here on the top. I think that the future-proof concept is extremely interesting. So here we have the concept. So future-proofs refers to the ability of something to continue to be of value into the distant future. In other words, something that's not going to become obsolete. The concept of future-proofing is the process of anticipating the future. When we look to the DOTs, a lot of times we're using some type of technology that has been the same technology for 10, 20, 30, 40, 50 years. So it might be a product that's approved on the qualified product list or approved product list, and we keep using that material, even though that material is something that's not going to last that long. But this is a big deal. This is a big problem. And one of the reasons is that we know that we have an aging infrastructure. So here, what we can see is that the number of structures that they're going to be 50 years or older is increasing rapidly. So we see here by 2050, we're going to have over 500,000 bridges, 500,000 bridges that they're going to be over 50 years. If you keep using whatever technology or whatever solutions or product that we were using before, that's not going to work right now. And the main reason why that's not going to work right now is that the situation has changed. We have an aging infrastructure, and we need something that's going to last longer than the traditional systems that maybe they last 3 years, 5 years, or they're not very easy to apply. So with this new situation, with an old and aging infrastructure, we need innovative solutions. We need innovative products. Here's the same thing. So we're still comparing the innovation, and one of the very interesting things about the ITD, the Innovation Technology Demonstration Work Group, is that this group is here to bring newer, innovative solutions to the existing challenges, to the existing problems. So we see that the efficiency in our structure is also increasing. And when it comes to innovation, specifically about construction, all of us here, we are in the construction industry. And it's not, it's not ideal when we see this chart and we see that construction is all the way on the bottom. So we have agriculture, manufacturing, mining. So we have a lot of other industries that the increasing of production was extremely huge in the last several years. But when we look specifically to construction, construction is all the way on the bottom. So the increasing of production in construction was about 15%. The average was about 50. Electronics was about 200. So it is very concerning to see this study. And so what they have done is that they went one step further, and they realized that the reason why innovation in the construction industry was the increasing of production in the construction industry was so low was because the construction industry usually plays the lowest bidder game. So the construction industry has a very thin margin. With a very thin margin, you don't have room to invest in innovation. There is no room to invest in new products, new technologies. So if you have a lower margin, that means lower resources for innovation. And that's not the situation with other industries. So here, it's very interesting again to see how we are way behind, and we understand that we have to change that. We have the opportunity to change that. When we're talking about innovation, we have two main types of innovation. We have the incremental innovation, and we have the disruptive technology. So the incremental innovation is the concept of growing or improving a technology or a product with a number of minor improvements. So in other words, when we think about, for example, um, iPhone 12 was a little bit better than 11. iPhone 13 is going to be a little bit better, was a little bit better than 12. So we know that every single iPhone model, the next one is going to be a little bit better than the previous one. So the name of that is incremental innovation. When you think about disruptive innovation, disruptive technology, is really something that's going to create a new market, or is something that's going to completely change the way the market understands or do business. So, using the iPhone example, when the first iPhone happened, maybe 10, 15 years ago, that was a disruptive innovation, a disruptive technology. So there was nothing like that. And then you have a technology, and now it's virtually impossible to imagine a scenario where that technology is not a part of our lives. So I have a number of examples here. So, uh, if we compare a lot of different industries, for example, we're going to see the same thing. Transportation, and we're going to see from from how it was before to driving an electric car, or when it comes to communication, how it was before, and now you can fly. You can be at 30,000 feet, and you can be using the internet while you're flying, or even communication. So we know that the way that we had these done before is completely different than the way we see right now. So more examples on how we used to do research before and now how we do research. And I wouldn't specifically for this one, I'm not even sure if Google, as of today, is the place where we research, or if that would be a chat GPT or AI. So something that's probably a few steps ahead of a search engine like Google. Uh, so I have a hard time understanding how my parents were driving without using a GPS system, and they're using maps and things like that. So again, this type of technology, it show us how important it is to keep innovating and to embrace innovation. And again, I can give more examples. This is the last one about shopping, how we used to do and how we do right now. But on the industry here, we have, for example, plastic. Before plastic, we have metal, we had wood, we had glass. And when plastic was created, that was a disruptive innovation. So it was a new technology that when this new technology happened, that completely changed the industry, that completely changed the market. We can give more examples about digital photos or streaming. But the main point here is that when we think about disruptive technology, we're talking about technology that they're really going to improve, and they're really going to change the way the market does business. When we put both of them together, when we've a few slides back, we were talking about the infrastructure package, and the infrastructure package is talking about future proofing or future proof technology. And when we understand about the disruptive technology, when we put both of them together, we understand, all right, we have an aging infrastructure. So we have an infrastructure that's just getting older, like everything. And for some reason, we keep using the same resources. We keep using the same tools. But now the enemy is a little bit different, because now I have a 50-year-old structure, actually not one. We have over 500,000 bridges that are 50 years or older, and these structures, I cannot keep using the same stuff that I was using 20 years ago, for some reason, just because it's one of my qualified technologies. So the ITD comes with exactly this idea to be a resource to really bring this innovation to the DOTs. And that being said, here today we have Mr. Brian Mintz, and a dear friend. Brian is the general manager. He's the director of Phoscrete, and Brian has been with the ITD from the beginning. So, Brian, thank you very much for joining us today. I would like you to tell a little bit about you and a little bit about the story behind the ITD program.
Sure, Mario. It all began back in 2013. I was at a Transportation System Preservation Partnership, TSP2. We have lots of acronyms in this industry, and it was a bridge conference. And all the industry members were in the exhibit hall. We were talking, and we all felt stuck because slow product approvals were holding everything back from being able to implement new and innovative products. And you duplicate this across 50 different states. So at that time, I came up with an idea and spearheaded the ITD program to fast track new bridge technologies to the DOTs. And the goal of the ITD program is it's about showcasing bridge preservation technologies effectively. The program lets agencies see and test these innovative products, processes, and services, and it facilitates quicker adoption.
Great. And Brian, how the ITD program operates?
Well, we organize real-world field demonstrations across North America. These are monitored by independent consultants. They collect feedback from the people doing the installation, they collect data, and we publish these in online reports. So this offers, unlike a case study from a manufacturer, it offers a balanced, real-world, independent perspective on each technology, and that information is shared.
That's great. And is the program successful? How has been working for everybody, for the DOTs and for the industry?
Well, it's been great. To be honest, it started with Phoscrete back in 2013, and we've expanded to 10 different projects right now, 10 different programs. We've received overwhelmingly positive feedback and encouraging even more collaborative demos across the DOTs around the country.
And just a quick note about that. I think one of the main things about the ITD is that sometimes you have the DOT engineers and they have a problem that they don't know how to fix. On the other side, you might have the industry or a chemist or someone that's working on a technology that they don't know exactly how to use that technology. But a lot of times, both of them, they're not talking. They don't know each other.
That's a really good point. One of the issues that we've experienced in the past is that, or actually I should say one of the benefits of the ITD program is interaction with the people in the field and developing a new and innovative product. We've improved Phoscrete based on feedback from the IT demonstrations, better ways to do installation, things people like, things people didn't like. We're constantly innovating and constantly improving to find better ways to solve problems for our customers.
Absolutely. And that was exactly the example that I was about to share when talking with the DOTs, the person that's actually applying the material, to hear their feedback and hear what they have to say about the product. Well, it would be great if, you don't have that, or if you have that, or if it lasts long, or if it dries faster, or the opposite. If it would be great if, it doesn't dry that quickly. So one thing that happened specifically with us, with Alchemco, was one of the feedbacks was, well, it would be great if you can reduce the amount of steps. And then we tried to figure out, how we can. It was at the point it was a 4-step process. We were able to cut from 4-step process to 2-step process, which for us, it was interesting. But when I shared that when I went back to the DOT, these specifically DOT, and I told them, by the way, we were able to do what you shared with us, and we were able to reduce the amount of steps from 4 steps to 2 steps. That made a lot of difference for him, because he was able, he shared that instead of doing, let's say, 20 bridges per year, now he's able to do twice as much. So he's able to do 40 structures per year just because we reduce the amount of steps. So this type of feedback that the industry receives from a DOT engineer, someone that's applying the material, it's really fantastic. And Brian, do you recall any challenge that happened with the ITD?
Absolutely. It actually didn't, it happened before ITD. It was over 10 years ago, and I was making a sales visit out to Caltrans, met with the district superintendent, and he showed me a competitor product that they had been using. In fact, he had a couple pallets of it on the shelf. And he said that he and the other districts were buying it and trying it, and they weren't interested in talking about Phoscrete at the time.
Mm-hmm.
Okay. So 6 months later, when we followed up, we found that that particular product had failed. And all the Caltrans district pulled that product from their shelves. Some of them began using Phoscrete, which was a good thing, and they still are to this day. But later that same year, at another TSP2 Bridge conference in San Antonio, I visited with a TxDOT district maintenance supervisor, and he shared with me that they were excited to begin testing that same product that was being used in California. And that just underscored the need for shared experiences to prevent such a waste of resources.
Absolutely. And what strikes you the most about the ITD? You have been the godfather of this group for so long, and it's funny because I met the ITD in 2020, and you have been doing that for 10 years. So you're really the pioneer. You're the innovative guy behind the ITD.
I'm the innovator guy behind the
Yeah.
innovation, but it absolutely that ITD's become a vital connector of innovation and practical application. It really does fulfill TSP2's mission perfectly.
Outstanding. And well, what are the next steps? What's the future of the ITD?
Well, hopefully somebody else is going to take over my job as the chairman because I've been doing it for so long. But we do see it as a key driver in bridge innovation. It should influence smarter decision making. It should enhance infrastructure efficiency and safety. And we're looking to add more products and services to the ITD program, more DOTs willing and open to participating in the demonstration. And we're also talking about expanding into the TSP2 pavement group. So our whole goal is to continue to provide dependable performance insights on new and innovative products.
Absolutely. So on our last remarks here, just before we wrap this up, I know that a lot of people watching this webinar, they are either an industry member that they have an innovative technology that they don't know either how to promote that or how to show this innovative technology to the DOTs, or we might have a DOT engineer that doesn't know they have a lot of issues and they don't know um, uh, how to best fix some of the issues that they have. I understand that a lot of you guys, a lot of the DOTs engineers, you guys are uh, critical to make the change that we need to see. So I always go back to my previous slide when I mentioned that 500,000 bridges, they're going to be over 50 years. They're going to be 50 years or older by 2050. So we have an aging infrastructure. We just cannot keep using the same technology that we have been using for 20, 30, 40 years because there's new stuff around. There are new technologies available, and these technologies can make our work easier. If you apply a technology, going back to Brian with Phoscrete, if you're able to resume traffic in a very short period of time, or if you have a technology like Brian that like Phoscrete that you are able to apply regardless of the temperature, even if it's cold or all of that. This brings a lot of value to your bridge. This brings a lot of value to the infrastructure. When we think about the future proofing concept, about using something that's not going to be obsolete in a few years, that's exactly the type of technology that we should always look for. So our company, we do a lot of business internationally, and sometimes when we're doing business in developing countries, what's very interesting is that I always ask them, why are you using our technology? Because I know that our technology is not the lowest, price technology around. And the feedback that I receive a lot of times from these engineers that they are handling bridges in Asia or in Africa. So it doesn't matter the continent, but in developing countries where they're very concerned about their money, the feedback is exactly what I learned from my father when he said, well, we don't have a lot of money, so we have to buy good stuff. So we cannot keep using, we don't have the money to buy the cheap stuff, and because that's going to break, and then we don't have the money to buy a new one. So I think that a lot of times these new technologies, they're not the lowest price, but often when you compare the life cycle cost of that technology, or when you compare other benefits that you're going to have with that technology, often that shows that this is a good path moving forward. So Brian, I think my last question to you today is that people that are interested in learning more about us, about ITD, what should they do?
Well, I have a couple of other comments because I think that you made some really good points. And the P2 and TSP2 stands for Preservation Partnership. And the Preservation Partnership is all 50 US states plus Puerto Rico. And Canada is also invited. So it's really an America's organization. And the goal is to preserve the bridges and the pavements and make them last. So we're not going to replace a bridge just because it's 50 years old, but if we design those bridges back now or starting now, and we continue to design and build bridges and use technologies like Alchemco's or Phoscrete or any of the other number of programs that we offer and other products that are out there, it's only going to make the products last or the bridges last longer, may preserve our infrastructure and save us from those the costs, which are not only construction costs, but the cost to the driving public. If they can't get from point A to point B, there's a huge cost in that. So if you're an innovator in industry who has solutions for the bridge preservation community, or if you're a Department of Transportation or state or local agency or even a port authority or an airport who's looking to trial new and innovative technologies to see if there's a better mousetrap than what you've been using all these years, I'd encourage you to go and visit the TSP2 website. The best place to find ITD would be to just go into your search engine and type TSP2 space ITD, and we'll come right up on the screen. And there you'll find detailed reports, case studies, and all the latest updates on all of our projects. We're really, truly grateful for everyone's interest and support in the ITD program. And I must say, it's your engagement that drives our innovation forward.
Absolutely. Brian, thank you very much. And thank you very much for attending today. Thank you. Have a good day.
Thank you, Mario.
Hey, I'm Dave Brodowski with TrueTech Bridge, and here to talk about ClearCast forms. This technology exists to address 3 pain points in the highway bridge industry related to bridge deck construction. The first is speed of construction. The second is construction safety, and the third is bridge preservation. We saw a need for contractors and owners to have a bridge deck forming system that improved productivity without compromising inspection of the deck. So we developed transparent stay-in-place bridge deck forms that have all the benefits of stay-in-place forms with the additional benefits of being able to inspect the concrete during placement, and then also over time for those routine inspections of the bridge. Through this technology, owners and contractors can achieve the quality and the long-term service life they desire out of their bridge decks, helping all of us get the most out of this investment. So here's the 2 primary views of the underside of the deck for bridges in the US. Looking at the big picture from construction productivity and safety to deck concrete quality during placement, to those routine inspections and then maintenance throughout the service life. You can compare the 2 options here. A new option, transparent forms, are a good compromise for contractors and owners considering the short-term and long-term goals of each. So ClearCast forms, all the proven benefits of stay-in-place forms in terms of productivity and safety. Now you can inspect the concrete during placement, and then you can also comply with MAP 21, AASHTO, NBIS, and then also in the future, as needed based on the deck condition, you can take bridge deck preservation actions. A few typical applications for clearcast forms. Railroad projects have been a very popular application due to the short working windows for construction, high flagging costs, and safety concerns. Also flyovers, these have height risks, working over traffic or pedestrians, always best to do top-down construction. These projects also typically have significant traffic counts, and the time to reopen them is critical. Utility conflicts requiring top-down construction since access from below is restricted, and really any bridge where stripping forms is dangerous or difficult for the contractor. For example, tub girders shown here, which have a confined space and very difficult and time-consuming to strip the forms. I want to point you to the AASHTO TSP2 ITD page, which has 2 reports on clearcast forms that were prepared by HNTB on the use of clearcast forms for a deck rehab project for NDOT. That was in LaPorte, Indiana, on the US 20 over I-80, I-90 bridge. And the report indicates productivity is as good or better as conventional stay-in-place forms. And then over time, you get the clarity and visibility that's expected. So contractors and owners, they can both agree on clearcast forms. Again, all the speed and safety of a stay-in-place form without compromising inspection. All of this results in better data to make better decisions related to maintenance and preservation in the future. So with that, I thank you and look forward to supporting you on your next bridge project.
Hi, I'm Erica alongside Brian Mintz from Phoscrete Corporation. We're here to learn about their innovative concrete repair materials.
Great to be here, Erica.
Brian, could you recount the moment Phoscrete's potential became evident to you?
Sure. It was February 14th, 2010, and I was watching the Daytona 500 on TV when a pothole brought everything to a standstill. That's when it hit me. Phoscrete could have patched that up fast and restarted the race hours sooner. It was a real light bulb moment, revealing Phoscrete's potential for rapid repairs on our crumbling infrastructure.
Brian, for those unfamiliar, what is Phoscrete MPC?
Phoscrete MPC is a user-friendly magnesium phosphate cement that sets quickly and bonds strong to regular concrete and to itself. It's ideal for time-sensitive repairs that last.
And how does Phoscrete manage to work so quickly?
Simply mix Phoscrete's dry and liquid for about a minute in a bucket and finish with a trowel. Repairs can be ready for traffic in as soon as 30 minutes.
And can you tell us about Phoscrete's reliability?
With 15 years in the field and approvals from over 24 US DOTs, Phoscrete has a solid history of successful repairs and satisfied users.
In such diverse environments, how does Phoscrete guarantee consistent performance?
Our thorough quality control and deep field experience ensure that Phoscrete consistently delivers, no matter the size or complexity of the project.
Can you tell us about a time when Phoscrete really came through for a customer?
Absolutely. A Caribbean food facility reached out to us in a bind. Their 100,000 square foot freezer floor had extensive concrete damage, cracks and spalls everywhere. Forklifts broke down and worker safety was compromised. Past repair attempts at concrete repair failed in the harsh conditions. They needed a rapid and effective solution. Phoscrete was the answer. Our technology, especially the F1 HC activator that mixes as low as -10 degrees Fahrenheit, allowed for overnight repairs each day without interruption, systematically addressing the damage. It's a prime example of how Phoscrete's specialized solutions come through when conventional methods don't measure up.
And reflecting on Phoscrete's journey, what resonates with you the most?
The Daytona 500 incident remains vivid. It perfectly encapsulates Phoscrete's rapid response and how it minimizes downtime, which is crucial for our country's infrastructure.
And as we look ahead, what developments can we expect from Phoscrete MPC?
We've pioneered new MPC formulas that work well in hot temperatures and for extensive structural repairs. Our latest, Phoscrete Formula 3, excels in pumping, overlays, and shotcrete applications, vital for structural integrity. These advancements are crucial for bridge and pavement preservation, and Phoscrete is at the forefront, ready to address the modern challenges of infrastructure repair.
And there you have it, a quick dive into Phoscrete's impact. For a deeper understanding, visit phoscrete.com, dive into technical specs, case studies, learn best practices,
or reach out. We're here to assist you with your concrete repair needs.
Thank you.
Bye.
Imagine a world where our aging hot-dip galvanized bridges and structures could not only last decades but forever, while preserving our environment. This vision is now a reality, thanks to Galvatech's rust anode primer technology. At Galvatech, we've simplified the bridge and structure refurbishment process with a one-coat system that rejuvenates the zinc layer and prevents corrosion. Our galvanizing compound rust anode primer is a breakthrough in hot-dip galvanizing refurbishment, making it more efficient and cost-effective than ever before. It acts like an active extra zinc layer of protection, giving your infrastructure a second rust-free life. Picture this: a bridge in Quebec, Canada, built back in 1968, got a facelift in 2017 using our rust anode primer technology. As time passed, from 1968 to 2017, the bridge faced the usual wear and tear. Zinc oxide, rust, and corrosion began to show up, thanks to weather and other contaminants. But then, the entire bridge received a coating maintenance. 5 years later, the local agency of transportation looked at how well our galvanizing compound rust anode primer had kept the bridge corrosion-free. The impact on everyone living nearby was huge. This isn't just about saving a bridge, it's about ensuring easy access for local communities who rely on it daily. When the Quebec Department of Transportation said yes to using our tech, it wasn't just an approval, it was a big thumbs up, saying, "This stuff works, and we must adopt this technology to preserve our hot-dip galvanized infrastructures." In 3 simple steps, Galvatech's rust anode primer transforms the way we refurbish bridges and structures: clean, apply, galvanize. It's that easy to remember. This innovative solution extends the life of these structures by decades and significantly reduces maintenance costs. When the next maintenance cycle arrives, you'll be dealing with a light zinc oxide layer, reducing costs on surface preparation, not paint peeling off surfaces. So, when you think of the future of hot-dip galvanized infrastructure restoration, think of Galvatech. We are leading the way with our galvanizing compound rust anode primer, making it simple and repeatable. Let's build a strong, rust-free future together.
My name is Tony Habadez, the inventor of Polysalt Armor, a breakthrough in bridge infrastructure preservation technology. In our roadways today, the big key word is bridge preservation, and as you can see in the words, to delay and reduce the deterioration of bridge and bridge elements restored and give the bridge its full function and concept. The problem with our bridge is what we consider the splash zone. As we all know, that the snow being removed from the roadway gets impacted onto the splash zone columns. And you can see from the pictures that the snow impact becomes the deterioration, which then becomes our way of processing and slowing the decay by patching and repairing. Our standard bridges are to extend to 60 to 75 years, and it's a major problem with a lot of DOTs, and this is a major component of the bridge. And as you can see in the pictures, sometimes we actually, because of the decay is so bad, we actually encase the profile. Repair costs are not sustainable. There's cost in mobilization, traffic control, prepping the damaged site, applying the concrete, and then reapplying the ineffective coatings that are in place today. So Polysalt Armor Shield technology provides a proactive, sustainable, cost-effective approach to DOT's requirements that provides longer life between maintenance, repair, and replacement. In our opinion, it's a true preservation tool. The next slide shows that the picture is worth 1,000 words as respect that we patched this bridge. They did the epoxy and the coatings, then we put our technology on, and then we pulled the technology down after 3 years, and it's still the same as it was when they did the repair. Polysalt Armor is a 10-year field study parts here in Ohio. Then we actually paid for an independent laboratory to confirm full life cycle. It is patented in the United States and Canada, and the material is made from a high density polyethylene virgin material with a UV stabilizer, and it is fully recyclable after its service life. Bridge safety ensures safety of workers and us as drivers. We have a savings because we have a lower cost per life cycle, and the sustainability of the material, it gives it good for preservation. One of the key attributes of the design is that the modularity allows for the inspection process. As you can see in the pictures, you actually can pull one panel down and the rest of the structure can stay there. As you can see, here's a timeline of where we're at. I mean, we are working with Ohio, Pennsylvania, Wisconsin, Michigan, Minnesota, and now New York. Advantages, disadvantages of the other technologies that we currently have is really the cost, and the value that my product provides is that it does have a suggested 25-year life cycle. It's 100% recyclable after its service life, and then it can be maintained and deployed by the DOTs. As you can see, that the high-level inventory of bridges within our states, looking at the amount of bridges and the amount of potential bridge piers sets that are out there, this technology could really have a big savings to all states and the Federal Highway Administration administering maintenance money to the different DOTs. So as Governor Mike DeWine addressed the 2021 Ohio Transportation Education Conference, every dollar that can be saved on materials, and if you got a longer life product that saves taxpayer money, and if it's a better idea, we're open for business. We believe that Polysalt Armor Shield technology is that better idea.
Today we're going to talk about Poreshield. It's an interesting product because it's sustainable, safe, and easy to use, but also provides tremendous durability to a wide variety of concrete. In 2008, the Indiana Department of Transportation came to Purdue University seeking a solution to provide a more durable concrete pavement joint. One of the solutions that came out of that research was a soy methyl ester polystyrene blend that can be applied topically to any type of concrete where it will be absorbed into the pores of the concrete to prevent fluid and ion deterioration and absorption in the future. So the idea of typical sealers for concrete is to limit the absorption mechanism and force that fluid to evaporate into the air. This coating is temporary because it can be worn down through abrasion, UV exposure, and other methods, whereas with Poreshield, you apply it topically to the surface of concrete where it is absorbed into the pores of the concrete, and it blocks that absorption mechanism but leaves no film behind on the surface. This means that the Poreshield protection will last a lot longer because it can't be abraded at the surface and it won't be exposed to UV. One big factor that is focused on for concrete deterioration is the use of de-icing salts or other exposure to chloride ions. When chloride ions make their way into concrete with water, that water will ultimately evaporate. The chloride ions will be left behind to crystallize. They can cause pressure as they crystallize and build up over time inside the concrete. They can also react chemically with the cement paste of the concrete to form issues such as calcium oxychloride formation. A common chemical deterioration type of concrete is alkali-silica reaction. The alkali environment of the pores can cause that silica-based aggregate to react with water to form a sort of gel or paste product that is expansive inside the concrete. With Poreshield protection, you apply Poreshield topically to the concrete. It is absorbed deep into the pores of the concrete where it remains a viscous hydrophobic fluid. On top of the performance and durability benefits of Poreshield, it's extremely easy to apply. You can see in this video here that all that's required is to remove debris from the surface. It can be done with a leaf blower or street sweeper, then applying Poreshield with a typical spray process and allowing it to absorb into the concrete of the bridge deck or surface you're treating. Since Poreshield is a safe and sustainable material, there's no concern for overspray into water or land. There's no hazardous fumes creating a concern for workers or the surrounding environment, and it's a hazard-free SDS. This product is 100% sourced and made in the United States. That means that it'll qualify for all thresholds of the Build America, Buy America program. Poreshield is also a low VOC technology at 43.3 grams per liter, no PPE CE or training is required for application, and the product is also a USDA bio-preferred product and is listed on the mandatory federal purchasing list. New uses for Poreshield continue to grow. We're by no means limited to the applications that we've done in the past or the applications we've talked about today. If there's an area of concrete that could benefit from the reduction of fluid or ion ingress, let's talk about it because it may be a perfect use of Poreshield, and that may be the way to make it last as long as possible.
S-lynks is a measurement, data processing, and reporting solution utilizing vibration-responsive bridges under ambient conditions. The data is then able to provide insights into short and long-term performance of the structures. S-lynks consists of a group of wireless triaxial accelerometers, cloud-powered automated data processing software. There are two main application modes of S-lynks, testing and monitoring. Testing mode is a short-term effort and includes the temporary deployment of measurement nodes on deck, towers, cables, or other elements of concern, followed by data collection. Data collection is typically done by roving up to 20 measurement nodes and collecting data in 20-minute-long durations at 250 samples per second. As a reference, a long-span bridge with a main span length of 1,250 feet can be completed within a day. The monitoring mode is the long-term application of S-lynks that includes the deployment of the measurement nodes on the structure for long-term. Monitoring mode can be scheduled once a week or on demand as needed. As a reference, when scheduled to collect data once a week, the monitoring system works up to 5 years without the need for battery replacement. Testing structures with S-lynks provides several insights regarding the performance of the bridge. These include identification of structural or cable resonant frequencies, mode shapes and damping, torsional behavior of long-span bridges for wind and earthquake, unexpected boundary conditions, piers, joints, abutments affecting global behavior, and validation of finite element model of the bridge. Monitoring bridges with S-lynks provides tracking the change in frequency, damping and mode shapes for baseline to determine structural deterioration, determining sudden changes before and after extreme events and estimating their location, understanding the effect of temperature and traffic on the modal parameters, and isolating from the actual response. For the state cables, S-link nodes are strapped along the free longitudinal length of the cable or group of cables corresponding vertical height. The data from cable measurements are processed to provide the following performance information: extracting resonant frequencies and overall damping of cables, force and stiffness estimation via nonlinear modeling, an assessment of susceptibility to rain and wind-induced vibrations. Some key differentiators of S-lynks are node-to-node synchronization of S-lynks is less than 25 microseconds with a noise ground below 30 nanoG per square hertz. The frequency response of the nodes is flat in amplitude and phase, providing a more accurate determination of mode shapes. And S-lynks data analysis is powered by the Stochastic Subspace Identification (SSI) algorithm.
BridgeDeck technology is a technology to waterproof and protect concrete structures, mainly bridges. The BridgeDeck technology is a liquid that's pre-applied to the concrete, penetrates about 3/4 of an inch inside the concrete, and after the penetration of the concrete, it's going to form a gel inside the concrete, sealing cracks up to 2 millimeters, so virtually the width of a car key. So if you can put your car key inside, this material is also going to be able to waterproof that crack. As the material is pre-applied, the application is very simple and fast. So we have the application about 20 to 40,000 square feet per hour per person. So you don't have to close your structure for a very long time. What's very unique about this technology, the name of the technology is is mechanically modified technology that forms the subsurface membrane inside the concrete. So there's nothing on the surface, all the reaction happens inside the structure. Here we can see a short video showing this reaction inside the concrete. This clear liquid is the product that's pre-applied to the concrete. We use a clear cup to show what's going to happen inside the structure. And you can see now this white gel. This white gel is what's forming, is what's sealing the pores, cracks, and capillaries of the concrete. And as I mentioned, cracks up to 2 millimeters, so the width of a car key. And if you don't have water, so if this product is waterproofing the concrete surface, you don't have water penetrating, so corrosion is not going to be a problem, freeze-thaw is not going to be a problem. This product is going to block water from penetrating as a real waterproofing product, not as a sealer, not as a viral repellent, nothing like that. It's a real waterproofing material. And here we can see the treated and untreated area. In the untreated, we can see the voids, the cracks, all of that. And after the application, we have that subsurface membrane blocking all the pores and cracks of the concrete. This is the video showing you can see this parking structure with a lot of cracks and water on the surface. And then we have the next video that we're able to see the underside of the structure. So here we see water on top because it's leaking, but now let's see the cracks. As we can see, all the cracks are watertight, and some of them we have stains from before, so we know that it was leaking before, but now after the application is no longer leaking. So what we can see here is that we don't have water penetrating in the concrete. So if water is not penetrating, we're not going to have corrosion or nothing like that. So these are some of the materials with this technology. The main difference between them is that some of them, they have a 15, 20, 25 year reapplication period, and I'm going to talk about that shortly. The main points about this technology for DOTs is first, it's a very short application. So the downtime of closing the structure, applying the material, and resuming traffic, it's very short. So you can do large areas in a very short downtime. The life expectancy, it's up to 25 years. So in other words, you don't have to go back to that structure for up to 25 years, which is amazing. A lot of technologies, you have to go back 3, 5, 10 years. This technology, 25 years. It's a flexible gel. So just like we saw in the clear cup, it's a flexible gel inside the concrete, that white gel, and it's going to work within the structure. So which is exactly what we need. We need a flexible solution when we're talking about a bridge. It's a very thin material, so it's going to penetrate even micro cracks in the concrete. The preparation is simple, so pressure wash is enough, and we need a dry surface for the material to penetrate in the concrete. The cost is low comparing to other technologies like methacrylates, epoxy overlays, all of that. And the life cycle cost, in other words, the cost of the material divided by the 25-year reapplication, it's very low. So this was an overview of the BridgeDeck technology that's part of the ITD. Thank you very much.